am D. Barman, Secretary of Indian Society of Coastal Agriculture Research. Warm greetings to all of you. It gives me great pleasure to extend a hearty welcome to today's workshop on towards self-reliance coastal agriculture challenges and way forward. Today we have eminent speakers, distinguished participants joining across India and abroad from different research organizations, government and non-government organizations. We have also with us honorable patrons, member of the Executive Council and other members of the society. Thank you so much for taking time out and being here today in this workshop of the Indian Society of Coastal Agriculture Research. I am sure that today's workshop will be meaningful, thought-provoking, and useful to all participants. Now we request Dr. H.S. Sen, the President ISCAR and the former Director of Central Research Institute for Jute and Allied Fibers, for his opening remarks and also for moderating the session. Dr. Sen, please.
Thank you, Dr. Barman. I hope I am audible.
Unmute பண்ணிட்டேன்டா தெரியுமாண்ணா.
Okay, very nice to see many faces which you are not normally familiar with to see them quite often. And I extend from my end a hearty welcome to all of you to this August workshop. And this is very important for us. We made a lot of preparations, and we have speakers from eminent speakers, 3 speakers from, very nice to see you, sir. Eminent speakers from India and abroad. And I think we will enjoy their lectures. We wanted to make it a diversified area of discussion, one on cropping system, followed by one on fisheries, and followed by climate change by the eminent people on the line. Now, with this few remarks welcoming you all, I suggest that I may start something on the coastal ecosystem at the President's speech. The total surface area in the coastal ecosystem is 26 into 10 to the power 6 kilometers square. Overall, about 50 to 70% of the global population live within 100 kilometers of the coastline, covering only about 4% of the Earth's land. Besides, the ecosystem is highly risk-prone and vulnerable, causing colossal damage to lives and properties, and this is further compounded due to climate change. I have divided the topic into a few important ones. Number one, that population and anthropogenic pressure. An estimated 23% of the world's population live within 100-kilometer distance of the coast, and population densities in coastal regions are about 3 times higher than the global average. Because of the rich resources, economic activities, urban settlements, tourist resorts, etc., the population has expanded exponentially in these areas, putting enormous pressure on coasts. In fact, none of the world's coasts today are free from anthropogenic interference. At this moment, I want to show you a slide very quickly. Can you see the slide?
Yes, sir. No, now it is not visible.
Okay, forget it. That was in Word. In fact, that's why it was not coming. My point is that there are few important areas that I wanted to flag. affecting the coastal ecosystem, its vulnerability, and the stability in turn. And our livelihood security is seriously at stake in the coastal ecosystem in most of the areas all over the world. Uh, Number one is population and anthropogenic pressure, as I mentioned already. The major impact of these human activities includes drainage of coastal wetlands, deforestation, discharge of sewage and other toxic substances into coastal waters. Next important point is the natural disasters vis-a-vis climate change. And we are going to hear one very illuminating lecture on this topic also. It is projected that the number of people living within 100 kilometers of the coastlines will increase by about 35% in 2050 as compared to that in 1995. This type of migration will expose 2.75 billion people to coastal threats from global warming, such as sea level rise and stronger hurricanes, in addition to other natural disasters.
Can you hear us?
Pardon? Pardon?
Marty, I'm Dr. Ghosh speaking. Can you hear
Yes,
me?
Yes, I'm hearing you. Yes, very nice to meet you, sir. In addition to other natural disasters like tsunamis, apart from the well-documented strategies in the past, a large number of national and international disaster warning systems and collaborations using advanced electronic and telecommunication networks.
Arman, you can remove the slide, you know. He's reading something and slide is something. So you can.
No.
Yeah.
Are
Okay.
you?
Yeah, now it is okay.
Using advanced electronic and telecommunication networks have been initiated at various levels, a detailed account of which is worth pursuing. It is projected from some quarters to combat the situation more systematically than there may be need for attempts for integrated climate change policies to be worked out over a large contiguous area, possibly subcontinent-wise. For example, for the Sundaman area, representing the largest delta with extremely rich flora and fauna, over a joint dialogue amongst Bangladesh and India. We can introduce some kind of climate change policy network discussion under the aegis of SARC, we propose, between Bangladesh and India. Next point is the crop and agro input management. The coastal areas in countries in general are endowed with abundant sunshine, solar as well as wind energy, precipitation, diverse soils, physiography, climate, etc., and therefore have tremendous opportunities for supporting a host of perennial and annual crops like trees, fruit plants, cereals, root crops, pulses, oilseeds, commercial crops, vegetables, etc. The future crop management lies in the evolution of better varieties through appropriate breeding strategies coupled with improved agro-input management practices for rain-fed and harsh agroecological environments. For an example, salinity, acidity, and flood for development or identification of genotypes with higher genetic yield ceiling under irrigated and rain-fed shallow lowland conditions, and consolidation of the already achieved yield gains in rain-fed and irrigated ecosystem. We need improved seeds or germplasm for varietal improvement suitable for the adverse ecosystem. Next one is seawater intrusion. I think on agro-input management and crop management, we are going to hear Professor Bell after a short while. Seawater intrusion. In view of the seawater intrusion becoming a significant factor for salination of the field, moving landward, it is necessary to develop location-specific optimization model to decide on suitable locations of the pumping wells and rates in withdrawal of the groundwater from these wells. Next point is soil quality, carbon sequestration, and SOC pool. So it has, however, been urged that detailed characterization of the coastal plains in respect to the soil quality should be undertaken in order to plan for such higher and sustainable productivity because of higher rates of carbon sequestration and lower methane emission. Coastal wetlands have been found to be more valuable carbon sinks. It is important to make note per unit area than other ecosystems in a warmer world. It is thus prudent to concentrate on elaborate studies in future on monitoring SOC pool in different soil strata in order to create data bank on SOC and monitor the changes in relation to different factors. Now, another important area is the change of the forest area, which is said to be dwindling over time. Coastal forests in developing countries are mainly mangroves, which cover an estimated 15.5 million hectares worldwide. The results of the trend analysis indicate that the current mangrove area worldwide has now fallen below 15 million hectares, down from 19.8 million hectares in 1980. The world has thus lost 5 million hectares of mangroves over the last 20 years, or 25% of the extent found in 1980. Mangrove deforestation continues, albeit at a slower rate, slightly slower rate in 1990s, at the rate of 1.1% per annum than in 1980s, which was 1.9% per annum. However, there are contradictory reports. WWF suggests more than 35% of the world's mangroves already gone. The figure is as high as 50% in countries such as India, the Philippines, and Vietnam, while in America they are being cleared at a rate faster than tropical rainforests. Next important area, flora and fauna facing extinction. It is further projected for Sundaban that up to 30% of the animal and plant species could be wiped out by a global temperature rise of 2.7 to 4.5 degrees centigrade, mostly because of climate change, hurricanes and surges, anthropogenic interventions, etc. The coastal and marine biodiversity is declining very rapidly due to increasing human population pressure on coastlines and brings multiple human uses and threats into the coastal marine environment. Anthropogenic threats have precipitated global disaster for coastal and marine biodiversity. Focus should be made on sustainable use of marine resources by public awareness of marine and coastal ecosystems, their productivity, biodiversity, value to humanity, and their fragility or exhaustibility that has increased greatly. Next important area is fisheries sector. We'll hear shortly on the fisheries sector also. The fisheries sector often accounts for a significant proportion of GDP, up to 5 to 10% of the economies of many developing coastal nations. A large proportion of the total fish production of many coastal countries is usually derived from coastal fisheries. At the local level, the fisheries sector provides a livelihood to the population and also contributes to food security. Annual average per capita consumption of fish is 9 kg in developing countries, 27 kg in developed countries, and 50 kg in small island states, which is equivalent to most of the population's animal protein intake. Coastal areas everywhere provide habitat for about 90% of the marine fish in commercial and subsistence fisheries. At all or some stages in the lives of the fish, coastal aquaculture has been growing in a number of industrialized and developing countries, particularly in parts of South and Southeast and East Asia and parts of Latin America. And there is considerable scope for development and expansion in other regions. Next, very important and emerging areas, not emerging, this is already established, coral reefs facing threats. Increased ocean temperatures and changing ocean chemistry are the greatest global threats to coral reef ecosystems, a worldwide phenomenon. These threats are caused by warmer atmospheric temperatures and increasing levels of carbon dioxide in seawater. The atmospheric temperatures rise, so do seawater temperatures. This warming causes corals to lose the microscopic algae that produce food that corals need, placing stress on the corals. Without this algae, corals will also lose their coloration, a condition known as coral bleaching. Last a few more points. Ecology and natural nutrient cycle, eutrophication and dead zones. On the ecological front, overuse of fertilizer can result in eutrophication and in extreme cases, the creation of dead zones. The influx of extra nitrogen by human interventions, which more than doubled since 1940s, has caused serious distortion of the natural nutrient cycle. In some parts of Northern Europe, for example, forests are receiving 10 times the natural levels of nitrogen from airborne deposition, while coastal rivers in the northeastern United States and Northern Europe are receiving as much as 20 times of the natural amount from both agriculture and airborne sources. Now, what you do, the task of the ICR. Now, this workshop is treated as a curtain raiser for the forthcoming international symposium that we are going to hold possibly in March. The Indian Society of Coastal Agriculture Research, through its publication, a large number of symposia and seminars in the national and international arena, vow to address the multitasking phenomenon with the target to prepare the roadmap on a sustainable note towards increasing livelihood security of the inhabitants who in majority of the developing countries live with abject poverty. These are all that I wanted to share with you from my end and from the end of the society as an introduction for further discussion to take place. Now is it Professor Bell's turn to speak? Let me introduce Professor Bell first. Professor Bell is a renowned professor of Murdoch University, Australia. He is a specialist in soil fertility and land management with teaching and research experience in Australia, Bangladesh, Brazil, Cambodia, China, India, Indonesia, Fiji, and Sri Lanka, as well as in Thailand and Vietnam. He has over 35 years of research experience on soil-plant relationships and crop agronomy. Professor Bell has authored 16 book chapters, 185 referred journal papers, 77 referred articles in book and proceedings, 26 conference and other non-referred papers, 73 papers, 73 reports, and edited 13 books. Much of the published work has concerned with mineral nutrition of crop and plants and soil management. He has supervised 55 completed PhD and master students, including several John Allwright fellowships as PhD students from partner countries. His first international project experience was as coordinator for a collaborative study with Thailand on the nutrition of food legumes on problem soil. Since then, he was engaged in a number of international programs as leader in the coastal ecosystem in several countries, including India. His total citation research publications is 5310 as of date. H index is 37 and I10 index is 139. Thank you very much, Professor Bell. You are welcome to make your presentation on your talk.
Thank you very
A sound problem?
I think you'll have to unmute.
Yeah.
Yes, can I check the volume?
Yeah, now it's okay.
Now it's okay, and you can see the screen?
Yes.
Excellent.
Yeah, that's right.
So, good morning all, and to Mainadine, good afternoon. It's my pleasure to give this presentation, and I really thank the Indian Society of Coastal Agricultural Research for the invitation, and particularly to Dr. Sen and Dr. Berman. The work I'm going to talk about is mostly from a project led by Dr. Mainadin of CSIRO, and it's a project that has been focusing on cropping systems intensification in the coastal zones of the Ganges Delta. And I'm going to talk about our research findings in relation to what we see as untapped potentials in those regions, as well as risks associated with new cropping systems. I'd like to recognise that this work has been funded by the Australian Centre for International Agricultural Research, which is an Australian government agency. Also the Kishi Gobishona Foundation in Bangladesh, as well as our partners. And in India, our partners are the CSSRI at Canning Town, BCKV at Kalyani, and the Tagore Society for Rural Development. We also have a number of partners in Bangladesh. So, sorry, I'm just looking for the slide forward option. There we go. Thank you. Most of you are specialists in this area, so I don't need to spend much time on the background or the context. We're talking about the Ganges Delta, which is this low-lying region, much of which is protected by embankments called polders in Bangladesh or islands in West Bengal, and the agriculture is largely within these areas. About 65% of the area is affected by salinity in the dry season, and the map there of Bangladesh shows the gradation of salinity from the coast going inland. Importantly, it's the home of over 60 million people who, in general, are disadvantaged by poverty, food insecurity, environmental vulnerability, and limited livelihood opportunities. So this is an area that deserves a lot of our attention. Across this area, kharif rice is the main crop, but in general, the yields are lower than in other parts of West Bengal, or in the case of Bangladesh, other parts of the country. And rice remains the only crop for large areas. So in this map, the pink areas show areas that are fallow during the dry season. So the cropping intensity in this region is somewhere between 130% up to perhaps 150% maximum, compared to most other parts of Bangladesh, where the cropping intensity is 200% or more. And the low cropping intensity is attributed to the late harvesting of rice, prolonged waterlogging, exposure of Rabi season crops to soil salinity, and the lack of irrigation water in the Rabi season. So we have a region which is dominated by rice, and then by a long fallow period where there's very limited cropping, but there are important livestock production industries that continue. That leads to late establishment of crops such as mung bean, and those crops may suffer from salinity. And then the late harvesting of Rabi season crops makes them very vulnerable to pre-monsoon rain, flooding, and the like. In our project, which was based on earlier work done by IRI under the Challenge program, the concept is to look not at the constraints around salinity, but rather at the opportunities around rainfall, because this is an area that does have high rainfall, and there are opportunities to change the cropping system. So the traditional cropping system is the traditional kharif rice, which might be transplanted in August and harvested December through January. Then when the floodwaters drain, some fields have Rabi season crops such as sesame or mung bean. They may not be planted until January or February. And then when they're harvested, you've got the early monsoon storms, which make them very vulnerable to damage. And then there's a fallow period. What we would like to suggest is that there's an opportunity to change this cropping system by growing medium duration, high yielding Kharif rice so that you can harvest that rice in November, drain off excess water, quickly plant high value Rabi season crops and harvest those crops in March, April before the monsoon storms. And there's even a possibility of growing short duration Aus rice. And what I'd like to show you today from our project work is some of the advances and evidence that we've gathered that this is a feasible change in the cropping system. The change in the cropping system, though, introduces some new important constraints in the early part of the season around waterlogging and salt interactions. Because the soils are wet, that makes them relatively difficult for mechanical tillage. And currently, those constraints lead to delayed establishment unless you can find innovative ways to establish the crops early. Whoops, sorry. At the end of the season, there are other constraints with reduced water availability, heat stress, high evaporative demands, water deficits, which is related to osmotic stress, iron toxicity, soil compaction, and cracking. And note that I didn't actually list salinity there as one of those constraints, and I'll talk about that later. In our project work research, we have focused on ways in which we might overcome those constraints. So changing the sowing time and method, introducing drainage, new irrigation technology, new establishment methods, using mulch, and using crop tolerance to those stresses. The paper I'm sharing today is based on a special issue of the Indian Society of Coastal Agricultural Researchers Journal, which appeared in 2019. And this was a collection of all the papers from Dr. Mainuddin's project. And the ideas that I'm sharing are largely drawn from a summary paper that I put together with co-authors from the project in Australia, in India, and in Bangladesh. And the photograph here shows the chief editor and the two co-editors of the special journal, myself and Dr. Mainuddin, with one of the contributors, Dr. Don Gaydon. So we do encourage everyone to pick up the special issue and read in detail more of the in-depth research. Our research draws on three key sites in the Umtali, which is a reasonably high rainfall area in Bangladesh, where the salinity level is moderate and where the site is close to a river that is fresh all year round. By contrast, at Duckhope, which is near Khulna, there is increased salinity. And then in Gossaba, even higher levels of salinity and lower rainfall, as well as the possibility of acid sulfate soils. So across this region, we have selected key sites that represent different levels and types of stresses that need to be addressed for coastal zone cropping. In developing this project, we saw a number of opportunities. The first one I've referred to, of changing the cropping season, which allows crops to use in the Rabi season water with low solute potential and avoid crop stress. But you can only do that if you harvest the rice earlier and sow the Rabi season crops earlier. Another opportunity is that canal and pond water mostly stays below 4 decisiemens per metre, and so it can be used as a strategic resource for supplementary irrigation. Another opportunity is to re-engineer the landscape to increase water storage and to drain land. We think Ausreiss is an untapped opportunity for this region. There are a number of opportunities for soil management to increase crop production. There is the opportunity to select for more stress-tolerant germplasm that Dr. Sen referred to earlier. There are, in fact, a diverse range of new crops, especially vegetables, that are suited to and could be grown in this region, and an interesting innovation that our project has experimented with, which is growing vegetables in paddy fields. I'm not able to tell you everything about our project because there's only limited time, so I'm just going to highlight some key issues and perhaps some new findings that we'd like to draw to your attention. The first I'd like to share with you is new understanding about the coastal zone environment and hydrology. And it's important for us to recognize that the Ganges Delta is not one homogeneous region. There are significant differences across that region that will impact on the cropping systems choices. First, we had a CSIRO scientist, Dr. Ying Yu, who did an analysis of climate and climate variability based on data, long-term data from 6 different sites, only one of them from West Bengal. And what we asked her to do was to look at issues of trends and variability relating to climate that we need to consider for particularly Rabi season crop. And this plot here shows the probability of exceeding different levels of rainfall. So 10 millimeters per day, 20 millimeters per day, 50 millimeters per day, and so on in the December-January period. So from her analysis, there's less than 25% chance of getting more than 10 millimeters of rain per day in that December-January period. But of course, during the monsoon, there's a very high probability of getting even more than 30 or 50 millimeters per day during that period. So it's this dry period that we're particularly interested in. And Ying did some further analysis of what's the likelihood of very extreme and sudden rainfall events during the Rabi season. So this is accumulated 10-day rainfall from early December through to late February. And the data is split between 2 decades, 1998 to 2007 and 2008 to 2017. And at first glance, you can see that the probability that the 10-day accumulated rainfall increases with time from early December onwards. But we wanted her to look into more detail. And the analysis shows that there's generally less than 50 millimeter in December, but through January and February, it's possible to get rainfall events over a 10-day period of more than 100 millimeters. And of course, these are quite important for the risk factor associated with Rabi season cropping. Some of the analysis suggests that in the last 2 decades, there may have been an increase in the prevalence of heavy rainfall in this early January period. So historically, we would have said mid-December to mid-January was a period of very low rainfall and low risk of waterlogging. But in fact, in the last decade, there has been an increased prevalence of heavier rainfall events. Canning was the driest of the locations in Dr. Yu's study, But even at Canning Town in the Robbie season, you can get some very heavy rainfall over a 10-year period from December through January through February. So the impact of this heavy rainfall on cropping risk is an important factor to consider. Dr. Yu also looked at temperature trends, and she found that all of the sites except Canning showed an increasing temperature trend over the last 25 to 30 years. And in the southeastern sites in Bangladesh, that temperature trend is greater. With rainfall, there didn't seem to be long-term trends from Dr. Yu's analysis. All of the sites here show pretty much, certainly they show a lot of fluctuation from year to year of maximum 5-day precipitation, but actually the trend is fairly flat across that period from the 1950s through to the current day. The second aspect of understanding the environment is through the work that Dr. Mainuddin and Dr. Matt Kirby at CSIRO have done, developing a polder scale water and salt balance model. Most of us, when we're doing research in the coastal zone, tend to be agronomists who are just looking at one small part of the polder. And what we're perhaps missing is an understanding of the polder as an integrated system. And so CSIRO has developed this polder scale model. It's a lumped model based on monthly data. And what they're looking at is key fluxes of salt and water. So of course, there can be water and salt fluxes from and to the rivers, from and to canals and ponds, from the saline groundwater into a freshwater lens, or from that freshwater lens into the soil. And they have validated this model, and perhaps Dr. Mainuddin might elaborate on the validation of the model if you're interested in more details of that. And then, based on the model, started to do some scenario analysis. One of the first things that we learned from the scenario analysis is that if you sow early Rabi season crops, they have access to a very significant store of reasonably fresh water. Whereas if you sow the Rabi season crops later, they start off with some fresh water stored in the root zone, but over time it becomes more saline. Another important aspect of polder scale modeling is that it's important to design drainage systems for polders to allow the release of saline water out of the polder. Otherwise, the salt is just continually recycling within the polder. So drainage system to get salt out and to only allow fresh water in is a critical part of the sustainable hydrology of polders. Another finding from the polder scale model is that the water in the canals and ponds remains reasonably fresh and can be used for irrigation, but currently the quantity is not very large. And the final piece of a scenario analysis they did is, if you have a well-designed drainage system in a polder and you get a storm surge from a cyclone, actually most of that salt potentially can be removed or leached out within a 2-year period. The modelling that IWM has done alerts us to another important aspect of the polders in the coastal zone, and that is the salinity levels in groundwater can vary quite considerably, and we need to bear that in mind when we're designing interventions and looking at what are appropriate cropping systems for different regions. I want to now talk about the key findings, some of the key findings from our cropping systems research. We looked first at what's the possibility of growing shorter duration kharif rice varieties and what's the yield of those. Fortunately, we have identified a number of rice varieties that actually not only have shorter duration and can be harvested earlier, but have increased yield in the order of 1 to 1.5 tonnes per hectare. And in Bangladesh, we've identified a few different varieties that farmers were quite satisfied with in terms of other characteristics. We realized that we only need to gain 15 to 30 days. We don't need varieties that are even earlier than that, because early varieties can be susceptible to rat and bird damage, and so that has to be managed. And the best way to manage that will be by block cultivation, so that groups of farmers in a block are all using the early maturing varieties and therefore can gather together to control rats and birds and drainage. In Gossipa also, our partners have found high yielding, early maturing Kharif rice varieties. And they've also been able to show that direct seeding systems can work in that environment compared to transplanting. And direct seeding is another way in which you can get earlier harvest of Kharif rice. In Bangladesh, we have experimented with Aush rice and found quite good yields in the order of 4 to 4.5 tonnes per hectare. The main constraint now with expanding Aush rice is finding enough fresh water for nursery preparation and for early irrigation. But we have been able to show some of our farming communities that simple interventions like putting temporary bunds across canals so that they store water is sufficient for them to establish a nursery and to establish Aush rice and get those good yields. Boro rice is of interest to farmers in the coastal zone, and there are good varieties that can produce quite high yield. But of course, Boro rice needs a lot of water, and we have some concerns about Boro rice. There may be some niches where in the lowlands where there is enough water for Boro rice, but in general, we should probably not be promoting Boro rice, but rather these alternative crops. And our colleagues at CSSRI are looking into salt tolerance and suitable sowing times for Boro rice. We've also found across 2 years in Bangladesh, perhaps to our surprise, that the alternate wetting and drying technology for rice does actually work on these salinized soils. We've been able to get the same yield with 25% less irrigation water. So if this technology can be scaled up, then there may be opportunities for more Boro rice than we currently believe is the case. Much of our work, though, has focused on the Rabi season and with many different crops. I won't go through all of them, but a great diversity of field crops as well as vegetable crops. And the research is focused around sowing time, establishment methods, mulching, drainage, soil amendment, irrigation and water management, and then putting all that together into suitable and profitable cropping patterns. One of the key findings across many different crops is the value of early sowing, that you actually get increased yields with early sowing. Here's 2 examples with maize and with wheat. With maize and wheat. The best yields from sowing on the 15th of November. Even after 30th of November, we find big drops in yield. In fact, across a range of crops, for every week that you delay after the 15th of November, you're losing 5 to 10% of yield potential. But there are some risks, and they're illustrated here with some sunflower data from PhD student Priyalal Chandrapal. What he found is that currently sunflower is being sown in late December through January, and the yield potential there is quite low due to drought and salinity and heat stress effects. If you plant earlier, you can get much higher yield potential, but there is a risk from waterlogging from the very early sowing. So here's 2 years. In 1 year, 4 tons of sunflower yield when there was no early waterlogging. In the next year, that early planting suffered from waterlogging, and so the best yield was from delayed sowing to the middle of December. We've also used APSIM modelling. This is a crop simulation model. Dr. Don Gaydon is an expert in that area from CSIRO. And using APSIM modelling enables us to scale out our knowledge over a wider range of climate variability, because of course every research project can only work for a few years in the field, and we may or may not encounter all of the range of conditions that crops are likely to be exposed to. So through calibrated crop simulation modelling, we can expand our knowledge of this environment. So Don's done this modelling here for wheat, growing wheat at different sowing times from middle of November to middle of January at duck hope. And if you assume that the soil is not saline, what he finds is that you get high yield potential sowing from November all the way through to the end of December, and it's only in January that the yield starts to drop off. However, when you introduce salinity to the soil, which is the real system at duck hope, the effect of sowing time becomes greatly magnified. So the very early sowing up to the 1st of December is where 50% of crops are going to produce 3.5 to 4 tons. But if you delay sowing after the middle of December, the yield drops off very sharply, so that sowing on the 12th of January on average is only going to produce 0.75 tons of wheat yield. Another important finding from our research is drainage. In fact, we would now recommend that no Rabi season crops are grown in this environment unless you actually install drains or have the capacity to install drains during the cropping season if there's heavy rain. So this is the findings of a PhD student working at duck hope in Bangladesh. In the control sunflower, it produced a yield of less than 1 ton. If we put in surface drainage, we can increase to 1.3 tons. If we put in subsoil drainage, we get similar yield. With a combination of subsurface and surface drainage, we're getting 1.7 tons. So almost a doubling of yield with good root zone drainage. That's the results from one experiment. We have the same results from a second experiment. Here's a heavy rainfall event on the 28th of February when the sunflower had been established. The surface water was pumped out, and then the surface drains drained off the further water from the root zone. The subsoil drains continued to drain from the subsoil. Here's the crop about 2.5 weeks later. The control is still very stunted and quite a few plants have died. Surface drains, subsurface drains have increased the sunflower enormously, but by far the best sunflower growth is with that combination of surface and subsurface drainage. And that's because it allows the water levels to drop very quickly. Within 2 days, with the subsurface and surface drain combined, the water level has dropped below 30 centimetres, whereas in the control, it takes 7 or 8 days before the root zone is properly drained. Zero-till potato has been an outstanding finding from our research, and this originated from the work done in West Bengal, where they're able to get very profitable zero-till potato crops. The potato is sown on the surface in furrows. It's then covered by a heavy rice straw mulch of over 12 tons. And then you pick the potatoes They come out very clean, and this is a very, very promising technology that farmers are very excited about. And we've introduced that to Bangladesh as well, and they, by following the technology developed in West Bengal, are now getting similar promising results. And so we're looking at how to develop the supply chain for seed potato in that region. We've looked at various water management technologies, including the conjunctive use of fresh and saline water, and that does seem quite promising. And low-cost drip irrigation technology has been very promising, particularly in Bosnia. And there's also considerable advantage in farmers putting in mini ponds. So our work, I think, demonstrates that cropping can be intensified in this coastal zone by growing early maturing Kharif rice varieties, and we've identified suitable varieties. Then by draining excess water at the end of the wet season, but that will need a community or block-based approach. We do need to get better understanding of the groundwater resource, particularly where there's acid sulfate potential. And there is the potential to expand the use of management of surface water storage, but that's going to depend on working with communities to cooperate on the use of water and the excavation of additional storage. The other aspects of intensification is early sowing and drainage of Rabi season crops, new ways of establishing crops on wet soils, which I haven't really talked about today, introducing more salt-tolerant cultivars, which we haven't really focused on, but there is promising research there. Alsh rice, certainly in Bangladesh, is a very promising option. So now we need to look at how farmers might optimize water storage on farms. What's the optimum area per farm for storage compared to crop production? And how are we going to manage the saline water tables during the Rabi season to reduce salt buildup? Mulches are going to play a significant role here. And also we have promising results with drip irrigation, where you can use water very efficiently on high value crops. So the next stage is looking at developing these new cropping systems to manage risk and develop these opportunities. We need to recognize that not all land is the same in the coastal zone. And so different technologies and crop choices may be suitable in different parts of the landscape. This environment is not just about salinity, it's also about waterlogging and about solute potential in the soil solution. That as we develop new cropping systems, we need to develop tailored agronomy for those new crops. We need to understand climatic risk, which does vary across the region and may be changing due to climate change. That we can use crop modeling to expand our knowledge of how to develop and apply these technologies. And of course, we need to understand the economics of these cropping systems. In some cases, we need to work on developing market chains and supply chains in order to develop new industries such as zero-till potato. And then finally, work with extension and with communities to outscale these findings to broader areas. And we're very pleased to announce that we hope to be able to continue this work for the next 4 years with ISCAR funding. We're also confident that in Bangladesh, KGF will continue to fund the work there. So in this new project, we're going to be focusing on this mitigation of risk and outscaling of profitable cropping systems that will help intensification of cropping in the coastal zone of the Ganges Delta. So I'd like to wrap up here. If you need more information, those are contact details from myself and Dr. Mainuddin. And I'd like to leave you with these slides, which show that we have spent quite a bit of time trying to dialogue with policymakers. We were very fortunate to spend some time with the agricultural advisor to the Chief Minister of West Bengal. And you can see here Dr. Mainuddin briefing him, and he discussed our findings in great detail. And in Bangladesh in March, they had a visit from the Agriculture Minister, who was extremely impressed with the type of innovations that we were able to show him there. So thank you very much. I'd be very happy to answer questions if there's time.
Thank you very much, Professor Bell, for wide coverage of the topic relevant to the coastal ecosystem, particularly in India and Bangladesh. I think it was an illuminating lecture, and I keep it open for 1 or 2 questions at the most, because we are running short of time. If there are any questions, otherwise, I request you and Professor Mainuddin to kindly sit at the end, because we have got some concluding remarks while we can accommodate some questions if participants can reserve their questions till that period. I too have some issues to be asked. Okay? If there is any question, you can make immediately some questions, short questions.
Deputy, Dr. Sen.
Yes.
Dr. Bale has covered quite a bit of Bangladesh situation. If you can add the portion of the crop diversification also Bangladesh, there's the sea change in the cropping pattern. Basically, rice fallows used to be used for the vegetable growing. Now, Bangladesh is the 3rd most important vegetable producing countries globally. And the per person consumption has gone almost 4 times in the last 1 decade. So if you can add in the intensive land management intensification, the other crops also other than the cereals, that if you can focus it.
Professor Ghosh, Professor Bell, I introduced Professor Ghosh. He is a very renowned scientist. He was Deputy Director General of Horticulture, and he spent considerable time in Bangladesh also. So his views should be taken seriously into consideration.
Yes, we have included a lot of vegetables in our research. I didn't mention those in detail, but certainly we understand that that's a great opportunity, and there are a number of vegetables that are showing very promising results.
Okay, thank you very much.
Sir, can I have one comment?
Just one question, please. That's
yes,
all.
please.
Yeah, please.
That is not a question. That is some comments.
Very nice to see you.
Yes, thank you, sir. The first point is, so far diversification of cropping is concerned, there are some essential oil-bearing plants which are hyper-accumulated in nature, and crops like vetiver, they can grow in waterlogged soil as well. Number one. Second thing is, in the coastal, water, there can be many organisms, vertebrate and invertebrates. That's a source of nutraceuticals. So these 2 points I can add when talking about the increasing economics of that area. Okay?
Okay, thank you very much. Professor Bell, for reaction, please.
Okay,
or you may kindly make note of this.
Okay, thank you.
Thank you.
Thank you very much.
We're focusing on systems intensification, but we recognize there are many more opportunities, and we're just focusing on some of them because it's just one project, and we recognize that there are many other opportunities, and hopefully other researchers and research groups are actively trying to promote those as well.
Thank you very much. Thank you very much. Okay, Dr. Bell, very nice to have a nice presentation from you. Very comprehensive presentation at the same time. Now, Dr. Barman, Dr. Jena is here.
I am there. Good morning, Dr. Saab. I am here.
Dr. Jena, please let me have the privilege to introduce you. We are 15-16 minutes late.
Yeah.
To start your program. Dr. Jena is presently the DDG Fishery Science of ICAR since 2016. His research areas have thrust on freshwater aquaculture and population genetics, notable being growth, nutrient retention, and digestibility, muscle nucleic acid content, gut enzyme activities, and whole body composition in silver barb, Puntias gonionotus fingerlings. The population structure and genetic divergence of Lobiogonius and of the Indian major carp Lobio rohita from three phylogeographically isolated riverine ecosystems of India. De novo assembly and genome-wide SNP recovery in Rahu carp, Lobia rohita, cryptic diversity in the Indian clade of catfish family Pangasilia, resolved by the description of a new species, genetic diversity and population structure of Syrinus migala, emergence of carp edema virus in culture ornamental koi carp, Cyprinus carpio koi, and many others. His number of citations as of date is 3318, H index is 31, and 810 index is 89. He has received a number of awards in recognition towards his contribution, and those in the very recent times include Fellow of the National Academy of Science in 2015, Rafi Ahmed Kidwai Award of ICAR 2013, past President, Asian Fisheries Society Kuala Lumpur during 2016 to 19. Now he is the chairman of the Asian Fisheries Society India branch 2014 onwards. Over to Dr. Jena, please.
Thank you very much, Dr. Senji. Good morning, everyone. Dr. Shen, President of ISCAR, all the members of the Executive Council of the ISCAR. I could find several of the seniors present on this occasion. Dr. A.K. Singhji, DDG Horticulture, I could see. Dr. D.K. Sharma, Dr. Pathak, Dr. Patra, and several others, and Dr. Sinababu. First of all, I would like to profusely thank Dr. Sen as well as Dr. Sinababu for giving me this platform to speak before you. I would be speaking mainly on aquaculture. Probably very few people present today who has background of fisheries, but as because the society is at West Bengal, I am sure most of you are fish eaters and you have some inclination on fish. Let me share the screen for my presentation. Is it screen is visible? Whether screen is visible?
Yes, sir.
Okay,
Yes,
thank
yes,
you.
sir.
Thank you. Thank you so much. Thank you so much.
It's visible.
Okay, thank you so much. Greetings to each one of you. This is an important day for all of us, a auspicious day, Ganesh Chaturthi. So sincere greetings to each one of you. Friends, I would take you along to the coast of India. My presentation, before I go to the my presentation, I would like to also mention how fish is important for all of us. We have been talking of fish for food security, protein security, nutritional security over these years. But today, when we talk of fish, we consider fish as a health food, a rich omega-3 fatty acid and all those vitamins A, D, and so forth. All of you probably are aware. So I don't need to mention. Just giving a few facts about the Indian fisheries. We are the second largest aquaculture producer in the globe, just after China, and of course third largest fish producer with about 13.4 million ton of fish production. If you see the growth over the years, all those growth has been mainly because of the aquaculture. Of course, vastly contributed by the freshwater aquaculture. Last 30 years, if you see the growth, annual growth rate has been 6 to 7%, which is unparalleled, you will believe. Export front, we have been doing well. Our export has been somewhere around 47,000 crores and contributing to about 20% of the agricultural export. So the importance of the sector is very well known. If you see the production trend over the years, you will find it is only last 30 years our production has been increasing very significantly because of the increase in inland fisheries, and that too contributed by aquaculture. The marine fisheries, which was substantially contributing to the fish production over the years, has been stagnating. All of us know the fishing generally we do up to 50-meter depth, and we have almost overexploited these resources. We need to go to the deep sea fisheries. Now, if you see the trend from last 70 years, from 0.5 million ton to about 3.8 million ton from marine fisheries, it is only capture fisheries. When you talk of fisheries vis-a-vis your agriculture, horticulture, and others, so and so forth, fisheries and is some sort of we do still depend on hunting and gathering, that is the capture fisheries, and also aqua farming, which has taken the first place at this point of time. Just to give one or two slides about the resources, when you compare with the crop agriculture, when you talk of coastal agriculture, it is the land-based agriculture, that is what we know nearer to the coastal areas. But when we talk of the coastal fisheries aquaculture, generally we believe it is in the sea and the very nearer to the only the land-based coastal aquaculture like shrimp farming, what we do. Along coastline, we have more than 8,000 kilometers with vast exclusive economic zone to up to 200 nautical miles from the shore, where you have the right for fishing and so forth. And I don't intend to give much these slides, the resources what we have, how many people depend on this sector, more than 4.5 million people depending on this sector for their livelihood and all, with so much of infrastructure component, whether lending center, more than 2 lakh vessels, whether mechanized, motorized or non-motorized vessels, which are operated all along the coast. Just to give, because my presentation is on aquaculture, but I thought just to give few slides on the marine capture, what we have been doing. We know the maritime states and union territories who are supplying the fish, and it is the west coast which contributes about 65% our marine production, and east coast, because it is a very depth is very high compared to west coast, and productivity of west coast is much higher. That's why about 35% our production comes from only east coast. And growth last 2 years, if you see about 6-7% growth rate, which is quite significant. But if you look at the right side graph, you will find that it has almost reached the stagnation. So we are depending only culture fisheries. Of course, pelagic resources has been contributing to the bulk. Coming to the future perspective, what we have the potential assessment for fisheries about 22.3 million ton. But at present, government has set up a committee to again review what would be our potential coming when we look at our resources, what we have, and the technological development has taken place. So in this direction, the government of India has set an ambitious target of 22 million ton by 2025. That means 7 million ton has to be added in the next 5 years with the export target of somewhere around 1 lakh crores, which is a Herculean task, but definitely we are working on that. How do we have a roadmap made and the programs chalked out? Friends, when we talk of export, bulk again comes from the shrimp aquaculture in the brackish water, the coastal region itself, the mariculture, which has not done much. We have been working on mariculture, sea cage culture, which I will be talking, but it has not contributed much. But our target before us is at least 1 million ton to come from the marine aquaculture. like sea cage culture, all those for high value species when you compare with the inland aquaculture, and several of the diversified groups. It is not only finfishes, but bivalves like oysters, mussels, and some of the seaweeds. Those are some of the focus area at present. Coming to the coastal aquaculture, we have, as I told, we are talking of the land-based culture. That means from the sea inside the land, maybe 5 kilometer, 10 kilometer, not beyond that. Of course, it depends the area where we have the space available and all, again intertidal zone, etc. So shrimp farming, major economic activity which is being operated at in all our coast. Of course, in recent years, crab farming and some of the diversified finfish farming is also taking lead. Mariculture is another new area which I will be speaking. Sea cage culture, bivalve culture, seaweed culture, and so forth. And another important area is the ornamental fish. Though we need to do in the land, maybe coastal waters, several of the marine and brackish-water species which are of highly economic importance. So at present, about 25,000 crores of export of whatever I told about 47,000 crores export, 25,000 crores comes from this coastal shrimp farming alone. Coming to the shrimp farming, of course, we have been doing traditionally fish farming in the berries and also in the Pokali areas of Kerala over these years, but those were traditional one. It is only in the about in 1989-90 we started commercial farming initially with few demonstration, and only species before us was the monodon, the black tiger shrimp or black tiger prawn, what we call. In about 4-5 years in early 90s, several hatcheries established, several intensive farms established. There was no risk, very high profit because export-oriented commodity. But after 5-6 years, we had major problem of disease outbreak. WSSB was a major threat. Since then, last 25 years, we are trying to manage with the presence of WSSB. Several environmental concerns, all of you know the CRZ, Coastal Regulated Zone, and all. So several of the farms were demolished. So there were problem, disease risk was there, but still there was a profit. There was a very high profit. Then in late, I would say in 2005 to 2010 onwards, we had a drop of global price. So disease, fluctuating profit, that was a major concern. That by then, another species we call Pineus benami or Lithopinius benami, exotic species which was introduced in the country. And that led to a gradual shift of our farming practice from monodon to benami farming. And today, if you see about 90-95% farms are only culturing benami. Shrimp production, if you see last only about 6-7 years, the production has gone 4 times from 2.2 lakh tons to 8 lakh tons, which is a huge jump rather. Culture area is less than 2 lakh hectare. What we say when we compared with the potential area available about 1.2 million hectare, probably only about 20% we have been able to use. So that shows what potential we have in coming years also. Production 6 to 10 ton, very easy, but people are going for a very high production also. This is the optimum production level. 3 to 5 lakh rupees net profit per hectare is minimum. That is what minimum I am giving. It can be as high as 8-10 lakh rupees per crop also. Grow-out farming, we have the practice adopted extensive to semi-intensive depending on the farmers' capacity to invest, because they it is a heavy investment farming technology. So, and over the years, there has been also emphasis on organic farming, new technology adoption like biofloc systems. Several of these technology has come in some of the areas in Andhra Pradesh and Gujarat. You can see adoption of new farming technology with very high production, with good water quality amelioration also. Several feed development. Initially, we were importing feed from whether it is Vietnam, Taiwan, Thailand, and so on and so forth. Probably today, 100% of our feed use has been from our indigenous production. We have had several problems of disease over these years. As I told, WSSB initially, later on EHP, several other disease which has been causing problem, but we have somehow tried to learn to live. That is what, like COVID. Initially, we were having so much of concern, but we know that this will be there, so we have learned to live. Similarly, this farming practice also, in spite of the fact that this is being a problem, but still our production, if you see, has been increasing. But we want to have some diversified species, alternative species. That is what on which we have been working. Indicus, Peneus indicus or Phenolpeneus indicus, what we say, Indian white shrimp having equally good market demand, both in domestic and export front. But probably we need to work on this on improvement side, which we are trying to do some work on selective breeding. If we can come out with high growth or disease resistant variety or SPF variety, probably time another 5 years, 10 years, we'll have replacement of Banami indicus with Banami with indicus. So that is the future target before us. That is what I was telling. Last few years, we have been demonstrating all along the coast, and with good production level, even 3 to 5 ton has been very common. All those places, even from West Bengal to Gujarat, all these places we have demonstrated. And if you see the cost of production, of course, it varies depending on the production, but the market price is somewhere around 350 rupees. So you have a high margin. But when you look at the future, as government of India has set a target of about 14 lakh tons by 2025, that means with the existing area, whatever production area, if we go for vertical expansion, probably we'll be able to achieve about 10 lakh tons with the resources, whatever we have been using at present. But for additional 4 lakh tons, we need to have another at least 80,000 hectares to be added. Of course, we have land area available all along the coast, but capital investment, it is not this capital has to come from the government, it is from the private investment, maybe somewhere around 8,000 crores investment need to be there if we want to add this 80,000 hectare in coming days. Several entrepreneurship requirement we need to have, because we are depending on the export oriented commodity. There are, as I told, their disease has been a problem. So surveillance program for containing any outbreak of transboundary diseases. We do not know what are the other diseases which may come tomorrow. Recently, there has been threat of another disease called DIV, Decapodidavirus 1, which we are also concerned, and we have started working on that. Area expansion is happening, but need to be regulated. All of us know there can be environmental fallouts, there can be salination of problems, so it need to be regulated, registered, and all those has to be done with due insurance and credit. All those things we need to do probably. Seed production is so important. Today we have about 550 hatcheries which are able to produce about 60 billion seeds. But if you need to expand to 14 for production of 14 lakh ton, that means our seed requirement will be somewhere around 120 billion. We need another 350 more hatcheries to be added. That means we need to have investment somewhere around another 2,000 crores, which need to come from the private sector. We need to have regulation, accreditations, SPF, seed quarantine facilities, several areas we need to be working in the coming days. Friends, as I told, organic farming is one of the area we have been working mainly for the niche market, for export market. Biofloc based farming, as I told, which has been growing very fast. If you see annual growth rate, 200 to 300% annual growth rate, because it was a new technology which has been implemented. What we foresee, if you see the recent year technology, people are talking only the seed of PL20 size, but we foresee that in coming years, the technology will be based on the nursery-based seed stocking. People will go for definitely nursery, which has shown advantage in terms of survival as well as the production level. So we foresee next 5 years, at least 25% of our production system will be depending on the nursery-based seed. So biofloc system will work, will be an important technology which need to be disseminated widely. And several diversification, because we have been depending on only a single commodity, that is shrimp. So we are working on several of the fin fishes. All of you know the vetki. We have been able to breed these species, a protenderous species, because initial years all will become male. All will become male. After 2 years, 3 years, the male change to female. So all those, so for a breeding purpose, you need to have a brood, a female which are of 3 to 5 years of age. So these were some of the hurdles, but we have been able to overcome. We have been able to breed milkfish, mogel, atropus, and even the crabs, which is, even if you see just in Andhra Pradesh alone, you will find at least 5,000 hectare sea bass farming is going on, vetki farming is going on. At least 5,000 hectare crab farming is going on, which are very high value species. All of you are aware, I am sure. This is one area we have not given focus at all. The country has never given focus. Even our neighboring country like Sri Lanka has done, their export has been quite substantial. Whatever our export from India has been only indigenous and freshwater ornamental fish. But last 5 years, we have been working at least about 25 different species of important clownfish, damselfish, and so forth. We have got breeding technology. One clownfish, even at our farm gate, if it is a good one, $10 to $15 we are able to sell. In general, for example, the designer clown, this mid one, a single fish we are selling at our farm gate price at 450 rupees to 500 rupees. That is the price I am talking. So a huge market in coming days. That is what we have been trying to explore. Open sea cage culture, maybe 20 years back, nobody thought that India also cage culture can go on, because all the time we know that our coast has been disaster prone and may not be suitable, and high tidal amplitude. That was the concern. But last 5-6 years, we have been able to see that our technologies are disseminated. And today we have more than 3,000 cages all along our coast. This is a scene you can see in some of the cages in Vizag areas and some of the Gujarat. You can see huge number of cages. And these are being done through SSGs mainly at present. Because small cages, only 6-meter diameter cages, unlike the cage size of 30 to 40 meter diameter, 50-meter diameter in Norway or Chile. Because ours a very traditional system, because they have a mechanized system, we need to have investment, more entrepreneurship. Several of the new species we have been able to standardize the breeding technology. For example, cobia, pompano, grouper, all those species are sold at 350 to 400 rupees at any market. A 6-meter cage is a small house-like size. You can have about 2.5 to 3 ton production. Maybe profit of net profit somewhere around 2 lakh, 2.5 lakh to 3 lakh rupees. I think, but we have to work a lot. As I told, our most of our east coast is disaster prone. So how do we do more steady cages, more strong cages and all in the coming days? But still we have been able to show that even in the heavy cyclone also, this cages retains. There is no issue. We have been working on the bivalve mollusk, mainly the oysters and edible oysters and mussel. Of course, not much production, about only 20,000 tons. We produce mussel, 20,000 tons. The oysters, mainly for the hotel industry and mainly in the states of Karnataka, Kerala, and the Goa area. Because in the this side, we don't prefer to have mussel and oysters. But in coming days, we find a huge prospect in the coming days. Kappa ficus, this is another important seaweed, which Honorable Prime Minister has been speaking. All of you know, last 4-5 years he has been speaking on the giving emphasis on seaweed farming as well as the ornamental fish farming. We have been working with the seaweed, some of the indigenous species like Gracilaria and Jellydiella, but over the years, there has been some exotic species. We know that how the seaweed they use, all of us know the seaweed use as a science student, all of us know the agar. That is the only agar all of us know. But the use in the pharmaceutical industry, cosmetic industry, and several areas has been quite immense. And we have been importing over these years, whatever. And some of the economics also we have worked out how it will be beneficial for as a livelihood option also. We are trying to integrate again the cage farming with seaweed. This has a dual advantage. One is when you have a cage with seaweed, you have a bioremediation happening. So much of amount of ammonia which is coming to the water get ameliorated because of the seaweed masses, and seaweed also gets the enough amount of nutrients, and production increases. And at present, we have been able to demonstrate the technology of IMTA in several of the areas, some of the fishermen society, SSG, and so on and so forth. This is, as I was talking of the seaweed shrimp farming growth, we need to be talking of feed. As I told, whatever the required feed, we are able to produce. You see, just in 6 years, we have been 4 times we have been able to increase our feed production. And whatever, even the next 1-2 years, whatever the increasing demand, our feed plant, existing feed plant will be able to meet the demand in the coming days. But if we are looking for 14 lakh ton, we need to have more investment. Maybe 1,000 crores investment has to be there in this sector, establishing in the new feed plants. Several areas we find entrepreneurship, prospect of entrepreneurship. For example, when you talk of probiotics, prebiotics, pond sanitizers, and so on and so forth, therapeutics, aerators and pumps, we have been initially we did import from Taiwan and Thailand. Today, everything whatever is necessary for this sector are being produced in India. RAS, FRP tanks, of course, some of the RAS are imported from the country like Israel. But time has come under the, we have been talking of, our Honorable Prime Minister is talking of Atmanirbhar Bharat. So probably in the coming days, we should be able to produce those required material, whether it is aeration device, whether it is tanks or anything. Several areas, packaging material, ice factories. When you talk of marine sector development, it is not only fish or fish production. There are several areas we need to be talking of today. Along with the production and productivity, the other important criteria when we need to give emphasis is the quality and safety aspects. So when we talk of fish, we know that by the time fish comes into the landing center, often it gets it gets spoiled or the quality deteriorates. For example, yellowfin tuna. The yellowfin tuna, by the time we get at the landing center, we get a price of only $1.50, whereas the international market price, other countries are able to get about $67. So we are talking of some of the systems with inboard processing facilities and all. I do not know. I think my time is up. Maybe I will wrap in 1 minute time. Several of the areas, laboratories, water soil testing, and disease diagnostic facility which are important at modern fish market, domestic market. That is what we have been giving emphasis. Processing plants, so much important. 500 processing plants we do have, but several of the issues we need to address, regulatory norms, quality issues which we need to be talking today. This is my last slide. I lead to entrepreneurship promotion, which is so important. For that, we need a policy. Of course, Government of India is coming out a national fisheries policy in coming days. We have been working on that. So, several institutional support is necessary, institutional synergy is necessary between the institute and organic and the private enterprise, investment, credit, market assurance, and all. But we have hope, because hope is definitely we are confident with the new ministry, new fishery department, new programs. Pradhan Mantri Matsya Sampada Yojana, all of you must be knowing. Honorable Prime Minister recently launched 20,000 crores investment in next 5 years on different areas. whether production, productivity, infrastructure, post-harvest, management, regulatory framework, everything is taken care of. So what we need to have is improved partnership between institution, enterprise and industries. Greater investment has to be coming. I showed some of the figure which need to be there. Government investment will be there, but more so private investment. If you talk of total marine fishery development or coastal aquaculture development, it is only because of the private investment which has happened. Improved value chain, production to production and marketing. We say farm to plate or boat to plate or farm to fork. That is what we say, farm to fork are so important value chains we need to be talking of. I am sure we are confident that we will be able to meet the expectation of the government, expectation of the Honorable Prime Minister in coming days with the program which has been being implemented at present. Thank you so much. Thank you.
Thank you very much, Dr. Jena, for his very comprehensive talk, and then he has left nothing. In fact, I was curious about some of the topics that whether he covers or not. And you know, ISCAR is placing a lot of importance on fishery sector in days to come. So thank you very much for your kind presentation and be with us. And I believe that we have not much of time left for the discussion at the moment. We reserve one or two questions at the end of this particular, at the end of the three session speakers. And otherwise, this was a wonderful lecture. He has left nothing. But I wish,
thank you, Dr. Sampson, for the opportunity.
Dr. Jena, I wish that you kindly prepare a kind of roadmap in a more quantitative form and then share with ISCAR at some stage on the coastal aquaculture issues and strategies. That is the topic. Thank you very much.
Thank you so much, sir.
I believe that Dr. Venkateswaralu is here.
Yes.
We are again late by 15-16 minutes. Dr. Venkateswaralu, you have got, let me have the privilege to introduce you. Dr. Venkateswaralu, starting with ICRISAT Hyderabad, later elevated as the director CRIDA in 2008 to 2014 and became the vice chancellor of Vasantrao Nayak Marathwada Krishi Vidyapith Parbhani in 2014 to 18. He had the major thrust in his research on climate change, abiotic stress management, and soil microbiology. He initiated research for the first time on desert microbiology and quantified the impact of sand dune stabilization on soil microbial dynamics, and later shifted his thrust on soil fertility management, biofertilizers, and biopesticides at CRIDA. As principal production system scientist of the National Agriculture Technology Project, NATP, more than 100 production system research projects were coordinated by him. Very staggering figure in the rain-fed agro ecosystem across the country, and subsequently coordinated the research programs of CRIDA as his director on rain-fed agriculture, 2 coordinated projects on dryland agriculture and agro and 1 network project, NICRA, National Initiative on Climate Resilient Agriculture, with an outlay of as high as rupees 350 crores for the 11th plant since its inception. Dr. Venkateswaralu is a fellow of the National Academy of Agricultural Science, NAS, became its member in 2017, member of the New York Academy of Science, and life member of the several academic and professional societies in India. He also became steering committee member of the expert group on integrated watershed management project, IWMP, of the Ministry of Rural Development, Government of India, an expert panel member of the National Disaster Management Authority. He published over 100 research papers. I believe that this figure should be much higher. 10 books and holds 1 patent. Total citations being as high as 7596, H index 43, and I-10 index is 159. Towards the research contribution he received in the recent times only, Vasantrao Nayak Award of the ICAR in 2009, Vasantrao Nayak Pratishthan Award in Mumbai in 2015, M.B. Shantaram Memorial Lecture Award 2014, Hari Om Ashram Trust Award of ICR 2015, and 7th International Crop Science Congress Award in 2016, and many more. Over to Dr. Venkata Solu for his inaugurating lecture, I believe.
Thank you,
We are
Dr.
hopeful for that.
Dr. Burman, I hope you will be able to, change, put
Dr.
the
Tashi
slide.
Dr. Tashi will do that.
I have some difficulty.
Dr. Mandal, we saw that slides.
Okay. Okay, right. First of all, let me admit that I really don't have much experience on coastal agriculture. As Dr. Sen said, I have been all along in dryland and rain-fed agriculture. And I, in fact, very reluctant to give this lecture, but Dr. Sen insisted that, whatever your thoughts on coastal agriculture, climate change, you can please feel free to share. So in the process, I could borrow some material from Dr. Patak, Dr. Mandal, and many others who are in different sections, different fields of the coastal agriculture, and then put these thoughts to share with all of you. The next. Now, I don't think I need to, tell about, yeah. So as you know that, the basic character of Indian agriculture, you all know, so I don't need to spend time on this. And we have, a lot of area under rain-fed agriculture. But since we are talking today about coastal agriculture, let us move on next, Now, next, Burman, just go on quickly changing, slides. We have to cover the time. Yeah. So this is again the Indian coast. I think many of you have already mentioned about the length of the coastline. Only one point I would like to mention. Of course, Dr. Sen also mentioned in the beginning, very high population density as compared to the other parts. And of course, globally, this is true all over the world. That because the more resources and all, more people live. Accordingly, when the disaster strikes, more people are also vulnerable. Next. Any problem with the presentation, Dr. Burman?
Mandal is presenting that one, I think.
Okay, Mandal. So any issue with the presentation or?
I don't know.
So I tried to give a overview of the various production systems in the coastal ecosystem, and you all know that the coastal ecosystem. You all mentioned about the diversity of its fauna and flora, and one important point I would like to highlight here is that I think there is no other country which has so many rivers flowing into both east and west. And many of these rivers carry a lot of silt and a lot of other nutrients into the sea, which is actually sustaining the marine ecosystem as we all know it. Next. Now, the most important production systems in the coastal areas, both you have agriculture, you have field crops, you have horticulture, you have livestock, you have poultry, you have fisheries. But obviously, when we talk, mostly we talk about crops and fisheries, but there are other sectors also which are equally important in the coastal areas, that is the. And coming to climate, as you know that in the last 100 years, we have seen a 1 degree rise in temperature, out of which actually last 2 decades saw almost 25% of this rise. So which means, going forward, the temperature rise will be more and more acute. And it is all projected by 2030, the 1.5 degree, the target is now being talked about. Next. Now, other than temperature, as far as the coastal areas is concerned, the sea surface temperature of the water is very important. Here also we see a very sharp rise in the last few decades, and it is also projected that in the next 50-60 years the rise will be much more sharper. And as you know that the sea surface temperature has a very significant impact on the marine fisheries, phytoplankton, and several other production systems in the coastal zone. Next. Now, as I just mentioned, that agriculture, horticulture, poultry, fisheries, and fish, all these sectors are extremely vulnerable to climate change, both to temperature, humidity, water shortage or excess water, etc., etc. And let us first see what are the major disasters or what are the major impacts of this climate change in the coastal ecosystem. One, of course, is the, because all India level, we don't see much change in the rainfall pattern, total amount of rainfall, but the extreme events, the distribution of rainfall, etc. As a result, we are now seeing, or in fact, we would like to see in future, more frequent floods and cyclones. About cyclones, one thing that I would like to say, many of you must have noticed that, in the last 2 decades also, the number of cyclones has not increased much, but the intensity of the cyclones, and that is actually is causing more damage. But fortunately, because of our better forewarning and advising and rehabilitation of the people and all, we are able to save much human lives as compared to the past. But our loss to the agriculture, horticulture, fisheries, etc., continue to cause a lot of economic damage due to. So therefore, the high intensity cyclones is one of the major hazard in the coastal area. And of course, when there is a drought here, normally about 25 to 30% of the fresh water in the rivers is supposed to reach the oceans. But as you know, many of our rivers like Krishna, Kaveri, etc., they are so close basins that there is, in a drought year, there is hardly any water flows into the seas. So as a result, it will have a lot of impact on the coastal ecosystem. And Dr. Sen also talked about increased salinization, sea level rise, temperature, humidity, etc., etc. Next. Now, out of all these effects, how all these effects actually impact the various production systems is something we would like to now see, and how we actually mitigate. And as far as the one of the thing which is most talked about climate change in the coastal ecosystem is the sea level rise. Of course, sea level rise is not very, because we in our lifetime generally, many of us, we don't get convinced on this, but people have been measuring globally at different gauging stations, not only in India but across the world. And in the last decade, we have been recording about 3.2 millimeters per year, and projected sea level rise is about 30 centimeter in 50 years. That means, about half a meter. Now, half a meter is not a small rise, and therefore that will have a significant impact on the coastal. And our ICR system has actually worked out the coastal areas, their vulnerability, both in the different states, the major coastal states. And you will see different, some states have very medium vulnerability, but most of them are medium to high vulnerability to, when there is a climate change, the loss to different production systems is something which we have quantified in ICR. Next. Now, the other issue is the intrusion of seawater. Now, the seawater intrusion is a major issue. In fact, in Gujarat, in Tamil Nadu, in coastal Andhra Pradesh, etc. Now, this is a slide in coastal Andhra Pradesh near Bapatla area, where you see many of the salts which are present in the seawater, how actually they are intruding into the sea, into the ground in the coastal area, and then you can detect them. So this is a major area. In fact, as we extract more groundwater, fresh water, then you see more seepage of the salinity. So this is a major hazard, which is not directly linked to climate change, but basically indirectly, because of decreased rainfall or more usage by the coastal areas, then obviously you will find more and more saline water entering into the coastal areas. Next. Now, the other issue is that how do you actually quantify these? Dr. Mandal, can you make little? Now, this is a very important work of canning station, as in fact Dr. Mandal shared with me. And in a time scale between 1973 to 2015, how the salinity ingression, how the salinity has, how much area, and you see there is a significant, increase in about in a lifetime of a person, so much. And of course, some of it will be changing depending on the rainfall and all. But Sundarban area is a very, very vulnerable zone as far as the salinity is concerned. Next. And likewise, almost you see in West Coast, in many states also you will find. Another problem of the coastal areas is the erosion. This coastal erosion is, when there is a sea tides, then unless the coast is properly protected, then you see continuous erosion. And people have to, even the habitations have to shift. And you see here, compared to the East Coast, the West Coast is much more vulnerable to erosion. And the East Coast, of course, in the West Coast also, most of the agro-tourism, or most of the Goa, Karnataka, Maharashtra, actually a lot of tourist spots are there in these areas. And we see many times, people have to, because people also encroach in these areas, and then next. So they lose their livelihoods when there is an erosion. And this climate change also is likely to increase the erosion problem in future. And as I said earlier, so the most devastating, of course, is the cyclones. And as you will see here, almost every sector, it's a crop sector, general houses, animals, every sector is drastically impacted, both in the East Coast and West Coast. Next. And in fact, most of us, we have been following this damaged cyclones, and the most recent in our memory is the 2016 Hudhud cyclone in Andhra Pradesh. And you can see in one district of Visakhapatnam alone, so much area of agriculture was damaged, both in all crops, rice, sugarcane, cotton. Especially the damage to horticulture is something very, very, serious, because, it's a lifetime investment for a farmer, a coconut orchard after 20, 30 years of, then suddenly loses everything, and then of course he can salvage a little bit, but it's a major loss. Next. So this is one major, if you have high intensity cyclones. And next is, of course, the rice, especially when you have a September cyclones, and when the rice crop is either harvested or just after harvesting or just before harvesting, if there is a cyclone, then there is a large scale flooding of the areas. And sometimes, you will see the whole crop after harvested gets washed or swept into the sea. And sometimes just before harvesting, the mature crop, the seeds germinate. And of course, people have been suggesting various, mitigation measures. But still, when there is a serious cyclone, a severe cyclone hits either Odisha or Andhra Pradesh or Tamil Nadu coast, millions and millions of farmers lose their paddy crop, and putting into enormous loss. Next, to their, livelihoods and incomes. Next. And so similarly, the same thing in case of sugarcane, rice, this is the same. So next, the kind of damage, and the universities and the ICR system has come up with several, measures. Another important effect of this temperature and rainfall fluctuations in the coastal areas is on horticulture. And see, in Konkan region, as you know, that Alfonso is a very important export-oriented mango from Maharashtra. And here, what is happening in the last decade or so, the sudden change in temperature and unseasonal rainfall in March is actually causing a lot of staggered flowering and fruiting in Alfonso. And this staggered flowering and fruiting means, you don't get all flowering at synchronized way. You will get every 15 days some flowers coming and then dropping, and again. As a result, the arrival of fruits into the market gets delayed. And once the monsoon sets in, the quality of fruits become very, very poor, and they will not be able to. So now a lot of work is being done both at IHR and also at Dapoli, Konkan Vidyapit, how to induce synchronized flowering in mango so that we don't face this problem of staggered flowering due to change of climate. Next. And In case of other crops also, the coconut and other crops also, there have been a lot of work done, and how to revive or how to salvage, how to save the orchards when there is a major impact of cyclone, like draining water, then taking some antifungal or disease control measures, etc., etc., some fresh pruning. But still you will be able to only save 25 to 30%, and you have to go for new plantation. Sometimes the damage is more than 80%. People totally uproot their orchards and go for a new plantation. So which is a very, the kind of relief the government provides also is not really commensurate with the losses. Next. And so it also, climate change also has an impact on the animal sector. As you will see here, the animals, the comfort of a milch animal depends on the THI, or the thermal temperature humidity index, which is a, so as you will see here, that 2030, most of the coastal areas will have a higher THI as compared to the interior, which means, more discomfort to the milch animals. As a result, the milk production will likely to decline. So this is where some investments on animal, improved housing for animals and etc. will be required. So this is another important dimension of the climate change in the coastal areas. Next. And then we come to the most important sector on the fisheries, which Dr. Jana has just talked about. And here again, there are different ways in which this fishery sector will be impacted. One, of course, is the coastal habitat, submergence, then increased erosion and a reduction in land area because of the the flooding, etc., etc. Next. So in this case also, the work done at CMFRI, our Cochin Institute, they have clearly demonstrated that the sea surface temperature rise and ocean acidification, the change in reduction in pH, will have a significant impact on the marine fisheries, their breeding habit, and they found actually, especially oil sardine, they have done a lot of work, and they found some states in the west coast, they are finding a decline in marine fish catch in the last say few years, last decade or so, and part of it they are attributing to climate change. We will see now next how it is. Next. Now, as you can see, just now Dr. Jaina has mentioned that the marine fisheries catch in India is actually getting stagnated, and as compared to the aquaculture. Now you see this one impact of this ocean acidification. They found is the more more carbon dioxide into the waters, more chlorophyll, but it also gets degraded faster. So as a result, the nature of the distribution of the different species of fish are likely to change. In fact, they're changing. So more less useful species might dominate as compared to the more useful. That is the kind of projections various fishery scientists are having in case of marine fisheries. Next. And this is, of course, the latest data on the landing. You will see, as compared to the east coast, in the west coast, most of the states there is a negative, catch impact. And as you will see here, the joint, of course, the idea of the plateauing, of course, there are many reasons, but one of the reasons is definitely the changes in the sea surface temperature and the ocean acidification and the phytoplankton, its availability, etc., etc. So these differences in different east and west coast is partly also partly due to changes in climate parameters. Next. And the other issues in marine fisheries, Mandal, can you little bit right? So in this slide, the entire effect of marine fisheries climate impact on marine fisheries is summarized, at one point, what are the variables, how they affect the intermediate process, and what are the biological impacts, and how it ultimately affects the fishery, total fishery. So you can see at different levels, there is an impact of climate on the marine fishery sector as a whole. Next. Now, this is again the various coastal, northwest coast, southeast coast, and southeast coast. Actually, the vulnerability to this catch has been worked out, and obviously you will see southeast and northeast coast. You see greater vulnerability in terms of high vulnerability as compared to the other areas. Next. So, and Dr. Sen mentioned about the corals. This is again well known, so I need not spend time on this. This is very, very important interrelated sector with fisheries, and there is a lot of bleaching observed all over coastal, both this is a Gulf of Kutch, Parkway, Andaman Sea we are seeing, and climate change also is speeding up this bleaching process in India. Next. And the other thing is that other than corals, other than marine fisheries, the aquaculture, the brackish water aquaculture is one economic activity which is contributing a lot of income. And in the last few years, whenever there is a cyclone hits, the damage in terms of monetary value is more to aquaculture than to agriculture, because of the high value nature and because of the high vulnerability of the aquaculture, the brackish water aquaculture to cyclones and high rainfalls. So you can just next 3 slides, Mandal, quickly, because they are all data of different cyclone events when they occurred, both in Tamil Nadu, Andhra Pradesh, what happened to the fish ponds, how they are actually marooned, and next, how they are marooned, and how the mangroves got disturbed, and how the people's livelihood has been, and how many farmers, how many crores of rupees each time, including the Chennai floods of 2015. So all this clearly demonstrates, next, the extreme impacts of the climate, both on the agriculture sector, on the horticulture sector, on the animal sector, and on the fishery sector, which are the major sectors in the coastal ecosystem. Now we spend a few minutes on the adaptation and mitigation. I mean, how do we overcome these issues? And one of the most important advancement we made in the last 1 decade or so is the submergence tolerant paddy variety, which is really a boon to the farmers of coastal areas. In fact, the Swarna variety is a mega variety in India. Almost 40% of the rice area is under this single variety, but it is very vulnerable to flooding. And now there is one submergence gene which has been introduced into the Swarna variety. As a result, I will see this slide on the left side, the place where you see the water, there the crop, the parental original Swarna got totally submerged. And whereas the genetically modified or the sub one, which is not a GM crop, but it is a normal breeding work, and that is now fully standing. And similarly, we are also having, drought tolerant work, which is also relevant in the coastal areas, especially in the rain-fed areas. Next. And this kind of advancements have really are helping the farmers, and more and more now, recent work shows, this is again another variety which Dr. Pathak has shared these slides. And here again, you will see, the submergence tolerance variety, how they are able to contribute to the better production despite the flooding and submergence. Next. Now, another, of course, before Swarna came also, the Angravu, they have also developed some simple methods, that they have MTU, some variety, and during Neelam cyclone in 2013 or so, at that time, under Nikra, one village, entire village, they have introduced this submergence tolerant variety. And also, whenever after flooding, they sprayed some potassium, So potassium spray and post-flood rehabilitation and use of flood variety, one village could save almost 45 lakhs just with single intervention. So we have some we have some we have some useful interventions, which are many of these interventions have been demonstrated in the, and similarly, the other, this is of course not directly related to coastal, cyclone, other things, but basically, how the improved methods of paddy in coastal areas can contribute to less greenhouse gases. Next. And then the other parts of the cropping is that, as we just talked about saline water intrusion or ingression, and traditionally in coastal areas, people have been using what we call as, little bit of fresh water available in the coastal areas in traditional ponds called doru, simple traditional doru. The left side is the traditional way they actually, and they can collect only limited water and they manually carry through pots. Whereas this our Acripon saline water of ICR, under that project, the Bapatla and Tamil Nadu TNAU, they have come out with a improved Durvu or Kotai technology, wherein they put cement rings and then they collect maximum fresh water and then pump it through, electricity or diesel. As a result, within a limited time of monsoon, they are able to collect more fresh water so that they can cover more, area for protective irrigation. And they are actually, this is another way of overcoming a mitigation of the saltwater intrusion. Next. And then with this kind of water, they are able to raise coconut, casuarina, etc., and try to vegetate the otherwise saline areas and also get some income from these degraded lands. Next. And the other way of mitigation, as you'll see in other sectors, and in NICRA project of 24 Paraganas, Ramakrishna Mission KVK, they have done a lot of work on this land shaping. The saline area, how by land shaping they can do in the same piece of land, both agriculture and fisheries, and optimize the income post cyclone. And this next 2-3 slides, Mandal, can you show one after another? These are just different examples of how successfully in, this is another, the same thing, of course, in a different way. On the ridge, you cultivate crops, vegetables. On the furrow, you cultivate veg. And these are all actual data examples carried out in NICRA and other projects through which, this cyclone impacts and saline water impacts are actually overcome. This is again the demonstration of how benefit Swarna variety can actually create in a village to the farmers in the farmers' fields, not just in the research for. Next. And similarly, next slide will show you the stress tolerant fish along with rice. If you integrate the Asian catfish, how much income a farmer can generate through this integration of rice and fish. So these are all various interventions. Under a climate resilient agriculture project, the ICR has demonstrated in different villages of the West Bengal. And this is again a slide from Canning. They have actually diagrammatically shown how this layout of these ponds can be there, where you can grow the farm paddy crop and fish and mitigate the impact of the cyclones and saline water. Next. And okay, next. And this is the impact again from Canning. They have shared this data. The actual economics of how this productivity, cost benefit ratio, net returns, and if you integrate paddy cum fish in this pond method of cultivation during in the saline, in the coastal areas. Next. So all this data give us a lot of confidence that, we can really, we can really, demonstrate, and we have scale up these interventions. The only thing is, and likewise, we have a lot of examples from the West Coast as well. This is in Kerala, where in the Kuttanad area, where the land level is below sea level, and there also, when the area gets flooded due to cyclones, even in 2016 cyclones, whenever there was the NICRA people were able to demonstrate that livelihood of people who were implementing these interventions was maintained even in the 2016 heavy rains and damage during Kerala. Next. So like this 2-3 slides next are other examples of how in the West Coast also these kind of interventions have been helpful. This is again in Odisha, where you integrate the rice with rice crop with other interventions and try to minimize the impact of cyclones into in the Odisha in village. Next. And this is of course then just now Dr. Jaina mentioned, I don't want to talk on this, but here what I want to say is the climate change mitigation also is possible through seaweeds, because they absorb a lot of carbon, they sequester carbon, and they also mitigate the eutrophication. And they, of course, they can be used as a bioenergy, as cattle feed, and Jaina mentioned about agar and many other economic activities. So therefore, seaweed should not be seen simply as a additional economic activity, but it is also a mitigation for climate change, and therefore it has a very great role. Next. And you can see the various kinds of economic benefits you can get from the seaweed cultivation, and it is very, very important, and a lot of industries can come up, and the products have a lot of high value, both for within India for feed and then as export as a chemical raw material. Next. Now, so we are now seeing same thing in a different perspective, from the mitigation perspective. Now, this is the total framework, adaptation framework for marine fisheries in India. So what is the influencing parameter? Sea level rise, salinity, chlorophyll, wind pattern, pH, GHG emission, and what are the various vulnerabilities? And then what are the adaptation strategies? In fact, I would like to share these slides. Dr. Mandal, you can share to all the people, since I really rushing up, and they can look at more closely. These are all material in the public domain, so that we have a better idea as to how we proceed in terms of the marine fisheries for adaptation to climate change. Next. And so we have last few slides. This is of course the preparedness in terms of mitigation measures, where we talk about structural measures like common dikes, flood walls. These are all of course investment requirements. You pre-monsoon inspection, then embankments inspection, multipurpose storage structures, etc. Next slide will show you about the non-structural measures, in terms of the preparedness, in terms of the vulnerability, and in where you need to focus, and preparing a cyclone hazard map, and preparing the zonation, and then taking up these measures depending on the vulnerability index at the national level, and mainstreaming it into a adaptation policy. Next. And so this basically these experiences teach us that for coastal disaster risk reduction, we really have to plan on a much on more scientific manner, taking into consideration not only the aquaculture but also the aquatourism, agrotourism on the coastal areas, and the general people's livelihood, marine, the animals. So this is how the coastal policy, how actually a remote sensing and other frontier tools can be used very effectively to prepare for a ideal or a scientific planning of coastal ecosystem as a whole. How we actually plan so that one activity does not interfere with other activity, and overall productivity from the coastal ecosystem is optimized. So this is possible, and many countries in Europe are doing it, and I am sure we can also do it. And SIBA has prepared such plan for Nagapattinam district in Tamil Nadu, and I was told that Tamil Nadu government will be implementing it, and I am sure the ISCAR can take up this kind of activities, Dr. Sen, and try to encourage this kind of all the states to come out with this kind of using of remotes, using of frontier techniques, so that integrated planning of the coastal ecosystem, so that the vulnerability to disasters is as less as possible when the extreme events actually take place. Next. I think the last but one slide we have now. And so this is one major message we have from the, and this is actually, the norm is actually they have been doing one work. A scientist in Norm has shared this with me. In fact, they did do this plan for a west coast in Sindhu district. They have planned each village. They have prepared a plan, considering the vulnerabilities of each village in terms of the number of households, how much fishery there, how many are freshwater, how many are marine, and what are there. So an integrated plan was prepared, and this actually Ministry of Environment will be implementing in course of time. So basically, one on East Coast, one on West Coast, we have seen an example how scientific planning, vulnerability assessment, and proper interventions can help in reducing the coastal vulnerability. But of course, as Dr. Jaina said, these things require a lot of investments on long term and which will definitely come from the public sector as well as. So this is the last slide, wherein I would like to summarize the recommendations as so as to reduce the vulnerability of the coastal ecosystem to disaster risks. One, of course, most important is the coastal regulation. In fact, India is one country which has the maximum number of regulations about coastal areas protection. But unfortunately, our implementation is very lax due to various reasons. I don't want to mention on this now. And now our new environmental impact assessment, I am told that it is further diluting these regulations, and ISCAR can actually study this new EIA and see its how actually is it really good, or some elements are there which need to be further debated and changed or modified. So Dr. Sen, this will be a major responsibility. The new law of environmental impact assessment, how they are actually changing the existing law in terms of the coastal areas protection and what we should do as a society. And then vulnerability assessment should do at the finer scale, more gauging stations for sea level rise. We have only now 3, 4. And then more vulnerability assessment to micro level, and policy level to be driven more by more data, and strengthening forewarning. We have improved our cyclone forewarning tremendously as compared to the past, but still there is a scope to improve floods and other vulnerabilities. And overall disaster risk, the NDRF, etc., whenever they come, they focus only on saving human lives. But the other things, the agriculture department, animals, they come little later. But by the time they come, a lot of loss already. So therefore, disaster risk, these climate vulnerabilities also should be treated as disaster risk and give more importance from the government of India. And of course, protection of wetlands, etc., etc. So thank you very much for this time. I think I have taken more time than allotted, but I'm sorry because I could not myself operate the slides. As a result, there was a mismatch between the slides and the speech. But overall, thank you very much, Dr. Sen, for this opportunity. As I said, I'm sorry, I never worked on coastal area, but based on my own understanding of the problems and the solutions, I just put together a small presentation. Thank you very much.
Dr. Venkata Sorlu, you said, and now also you say that you have no personal expertise in the coastal ecosystem. The way you projected, it was really mind-boggling. And particularly, I take your future suggestion. Your suggestion for ISCAR to work upon these future strategies to be developed in agriculture and allied fields vis-a-vis coastal disaster, climate change policies and all that. I take your point. We'll be in touch with you to take your suggestion in future for all these areas. Now we are already late, so we have got another small in-house program to start. So I thank all the speakers. I believe all the speakers are here. So if there are any question from, I had a certain set of points, but I keep them reserved. Maybe you are late, so we may not go into that. But if you have any question, you can ask. Yes? Dr. Patra, you can unmute. Please unmute. Dr. Patra is speaking, no? Yeah, please, please, please unmute. You are not audible.
Not now.
Now it's all
Yes.
right. Okay. Short
My
question.
only request is like this. Plantation crops are very important in coastal ecosystem. And if you say both east coast and west coast of India has got quite a good number of crops, right from cashew to alfonso mango to coconut to spices, export-oriented crops also. And these are perennial crops. So some simulation models for coconut CPCRI tried once. I think some prediction models, for example, we have got coconut west coast tall and east coast tall. In addition, we are multiplying D into D hybrids also. In the cyclone prone area, whether we'll be switching over to dwarf types to reduce the disaster effect, impact less, or we should go. Then accordingly, we'll have to go for the CDB and other thing production of the planting material. All our paper presentations should have some developmental focus. And as Dr. Bekwishul has suggested lastly, adaptation, mitigation strategies. Strategies we have done plenty. But somewhere the examples, experience sharing, the positive experience we got it, paper if you contest, the other can follow the same pattern. So my request, if another paper can be invited from the DDG horticulture, like the fisheries has covered, or from the plantation, at least from the CPCRI Kasargod, they have done wonderful work in the, for example, some genotypes of the, they found where the stomatal count is more, so desiccation pool is more, so don't put in the drought prone area. So that type of scientific supporting data will be helping us. So from the organizing side, if you can write to CPCRI director, he can present it.
Yes,
Thank you.
I think you are very correct. You are very correct. And I can tell you, as the beginning, I said the very first sentence, this workshop is a curtain raiser to the international program, where I've got all the issues relevant to coastal agriculture and allied activities under consideration. CTCRI, CPCRI, everybody has been included in that program for major issues to be flagged. So this will not be left out. This is only miniature scale workshop that we wanted to have, just to have an impression of what is happening. But I believe that this has been a fantastic workshop with the three speakers put all their efforts to cover comprehensive areas in the respective fields. And we have decided to make it a diversified topic. Thank you very much, sir, for your comments. Yes, Dr. Patra, you wanted to say something? Please, quickly. You have to unmute. Yes, Dr. Patra, you are still not unmuted. Who is the next person then?
Can I make a quick comment?
Yes, please. Please, one or two only. We have no time.
Very short. Thank you very much. We are working for a long time in the coastal zone of Bangladesh and then West Bengal and other parts of India also. We found that the technologies are there. There is huge technologies generated, but the scaling is not there up to the mark. So what are the reasons? The reason is that probably is that the hydrology is, the agriculturists did not include the hydrological issues. So the coastal hydrology is different from other parts of Bangladesh. There are tidal, then hydrology are there. So these types of water management or hydrological issues, if not incorporated, then whatever the technology we develop, it is not possible for an individual farmer to adopt. That is my comment. So I think
yes,
the society.
Yes, Dr. Mandal, I fully agree with you.
Yeah.
I fully agree with you with all my experience in the field of water management, hydrology, and all that. And this issue has to be flagged and given high importance.
Yeah.
I believe that the Professor Bale is here. I'll ask him to kindly consider the tidal river management program, which was initiated in Bangladesh quite a few years back, and possibly by Dr. Ainun Nishad. He is an engineer basically, but spent entire life on Sundarban area on agriculture. He is a pioneer worker in this. I believe I was impressed. This kind of work in a mega scale is very important to be given due consideration. Yes, next one, please. Next person, please.
Hello.
Yes, Dr. Saab, boliye.
Me?
Yes, you wanted to say something?
Well, good afternoon, everybody. This is Ankit Yagi. I want to congratulate the organizer, particularly Dr. Sen, his team, for organizing such a wonderful workshop in a very short time.
Thank you very much.
And so far as the issues of water management in coastal areas are concerned, I think the professor from Australia, Murdoch, he has very ably described the situation of, with regard to rainfall changes, with regard to the water courses, with regard to the storage that is required in coastal areas in the form of either drainage, these you can say rivers, which flow only during monsoon time. I remember that a long time back, we thought of a plan to suggest to the Sundarban board for converting these derelict channels, which are there in large numbers, and they during rainy season flow, but after rainy season there is no flow in them. So those channels, suitable, you can say, check structures could be utilized for saving water. I also saw Professor Pankreru very rightly mentioned that it is not the question of only production, it is also the question of mitigation. And the seaweeds are a good source of mitigating the carbon because they consume a lot of carbon dioxide. In fisheries, I saw that they are moving towards cage culture. But last year, as you know, Dr. Sen, we published that paper in which the vertical sea farming, where you can grow different types of weeds as well as fish of different types in controlled environment without any input. That will be a wonderful thing that can happen to the coastal aquaculture, which is, I consider, a part of agriculture. Since you are already short of time, I can only say that congratulations and keep it up. I know that in spite of many, you can say, health problems, you are doing a marvelous job. Thank you very much.
Thank you very much, sir. Anybody else? Anybody else? Dr. Sharma? Dr. Sharma, I have been seeing you from the very beginning, but you have been completely silent. Any question or comment?
Okay, I want to share some of the things. Can you hear me?
Yes, we are hearing you.
Yeah.
Very quickly.
Yeah. Yeah. The presentation of our three learned speaker is very nice, informative, and also the in-depth. And these are the Dr. Jaina, Dr. Venkatarsallu, Dr. Bell. And it is very high time to have the discussion and also the information of these discussions. So in the future also, we can also see the other things, and in our journal we can publish these discussions and also the presentation. So it is worthwhile to have the each volume we have the in-depth paper presentation in our journal. Thank you very much.
Thank you very much. Thank you so much, Dr. Sharma. Now, let me if there are no more questions, in fact, we are running seriously short of time. I request Dr. Burman to kindly propose the vote of thanks.
Thank you, sir. Honorable speakers, dignitaries, distinguished guests, and dear participants. On behalf of the ISCAR, I feel immense pleasure to take this opportunity to propose vote of thanks. We express our gratefulness to our eminent speaker, Dr. Richard Bell, who spared the time from his busy schedule to speak on the very important topic on opportunities and risk for cropping system intensification in the coastal zone, especially in the Ganges Delta. Thank you very much, sir, for being with us today in this workshop. Let me express my gratitude to Honorable Dr. J.K. Jena, DDG Fisheries ICAR, for his thought-provoking insight on coastal aquaculture development in India. Thank you very much, sir, for sparing your precious time with us. I further extend hearty thanks to Dr. B. Venkatesh Saralu for delivering and sharing knowledge through your experience, insight, and perspective has been an utmost value to each of one of us here today who has attended the workshop. And I take this opportunity to especially express my deep gratitude to Dr. H.S. Sen for always encouraging us, guiding us, and providing opportunity to organizing such event. Respected participants, I am very glad and thankful to each one of you for your valuable presence and support, which is highly appreciated. We are on behalf of the ISCAR, we are very much thankful to our senior persons who are attended today, like our patron, Dr. S.B. Kardekar, Dr. A.K. Bandyopadhyay, Dr. N.K. Tyagi, Dr. A.K. Singh, and Dr. D.K. Sharma, and others. And many other persons we have joined today, very important dignitaries like Dr. D.D. Patra, Dr. S.P. Ghosh, Dr. Moinuddin from CSIRO, Dr. Pathak, and Dr. Gopal Krishnan from NIH, Dr. A.K. Varma, and others. And I could see my senior teacher, N.V.K. Chakravarti, who has joined today this program. We are very much thankful to all of you, sir, for joining with us. We have special thanks to Dr. Manoranjan Mandal from Bangladesh, Mr. Bilal. I could see the Dr. Priyalal